The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
I'm going to talk about Chapter 9, which is construction, Chapter 10, which is quality assurance. This code assigns certain responsibilities to the licensed design professional. I'm going to focus on those responsibilities. Starting with stability and temporary shoring requirements. Typically, the design of shoring and bracing is the responsibility of the contractor. I'm going to refer to AIA Document A201, which is the general conditions used on probably most architectural jobs in the United States. And in it states that the contractor shall be solely responsible for and have control over construction means, methods, and techniques. Section 9.1.1 of the code states that the contract document shall define the temporary shoring and bracing requirements for all phases of the repair project. It goes further to say in the commentary that the load, spacing, and placement requirements for temporary shoring and bracing at all phases of a repair should be conveyed to the contractor. This is language we put in our general notes. You may use similar language in your jobs. The contractor is solely responsible for all methods and means of construction and job site safety. And the contractor is responsible for the design, installation, and performance of all shoring and bracing. But this is unique to repair work. We have a note that says, provide and install all shoring and bracing prior to the removal of concrete. And that's in case something dislodges or there's changes in, as you take these buildings apart, there's changes in moment distribution and so forth. So it's really important to pay attention to that. Temporary shoring and bracing shall be designed by a licensed design professional. Typically, the contractor hires their own LDP for this task, but sometimes the licensed design professional for the project may perform this task. Adequate shoring and bracing of active members shall be provided during evaluation and repair construction. Typically when you start, you may not have any shoring, but there are times when it's necessary. This is a project that we had. It's a second level of a parking structure. We went in there, we got very concerned when we saw the radial and circumferential cracking. And along with other tests, we determined that we have a real issue here. So we had that shored next day by the contractor helping us with this work. And it's a good thing. This garage was built in the 60s, and it had truss bars. And for what we found when we were repairing it, that the truss bars fell over. And essentially, in some spots, there was no top reinforcing. Temporary shoring shall be designed to accommodate in-place conditions in the structure and expected superimposed loads. It is the responsibility of the LDP for the repair to assess the impact of the shoring on the existing structure. Here's a case in point where there's a complete balcony replacement on this condominium building. It was actually our project. We had to check how many levels of balconies did that shoring have to extend down to till we picked up the construction loads. Code requires that global stability shall be maintained prior to and during all stages of the repair project. Global stability is defined as the stability of the overall structural with respect to uplift, sway, instability, or sliding failure. We're very concerned about the effect and modification and repairs to the lateral bracing system, especially for columns. If you remove a slab framing into that column may be a two-story column. And commentary indicates that lateral force of 2% of the axial load is commonly used for the bracing force. Here's global stability. This shoring was designed by the contractor's licensed engineer, it's LDP. The reason that's necessary is that this complete second level of this garage was removed. So these are freestanding walls for 2 stories. Here's the interior of that same garage. We were concerned about buckling of that column, so the contractor's engineer designed this shoring system or bracing system. The design of shoring and bracing during the repair shall account for a removal of existing adjacent framing and shall consider changes in load paths. This is a continuous beam. Actually, this is for slabs, the intent here. If this member is removed, then you're going to get an increase in positive and negative moments. We have a note on our drawings, typically, that if there's going to be removal of framing, but that the adjacent bays be short. And the reason we do that is to minimize the impact of increased positive and negative moments, and otherwise you're locking in these forces in the adjacent members. So we want to deal with that. This is a complete bonded overlay on this garage, so everything is short. Obviously, the strength is reduced while that work is being done. Where existing structural members support the structure and those generated during the evaluation and the repair, the design strength of those members need to be evaluated. Here's a case in point. This is for a parking garage. They had to bring the concrete in, back it over this driveway, which is a supported slab and framing. So we found that when we checked this, the beams and columns and girders beneath this were fine. However, the slab wasn't. There was some punching shear problems. So the solution by the contractor was to install steel plates. Load and load factors during the evaluation and repair construction process shall be in accordance with section 5.1.4, that was discussed earlier. Essentially, if the building is occupied, it's ASCE SEI 7. If the building is unoccupied, it's ASCE SEI 37 needs to be used for the loads and load factors. The contract documents prepared by the LDP shall instruct the contractor or other designated party to be responsible for all specified environmental remediation measures. And the contractors have to instruct, or shall instruct the contractor to report any new conditions encountered, including environmentally hazardous conditions. Referring back to this AIA 201, that states that the contractor is responsible for compliance with any requirements included in the contract documents regarding hazardous material. But they also state this, that if the contractor encounters a hazardous material or substance not addressed in the contract documents, the contractor shall stop work immediately and report that this condition to the owner and the architect in writing. Here's a case study illustrating contract documents defining temporary shoring and bracing conditions. This is a university building in Chicago. The objective here was to add a auditorium, and above that auditorium a ballroom. And to accomplish this, we had to remove 3 columns. And so we frame to the columns to a new truss. It doesn't show here, but we have a truss framing 3 bays. Let me go back again. We have the section here across that, in front of that framing, and we give the loads to the contractor, and we also have a note here that says the contractor to design temporary shoring system to relieve force in column prior to demolition. It's very important. And we also gave demolition sequence notes. However, the contractor decided not to hire his own engineer. He hired us instead to do this work. After we got permission from the university and we got our proper releases in place, so we limit our methods of mean just to this work, we did it. We prepared a set of drawings to take care of that phase. Now our client is the contractor. We had some pretty extensive construction sequencing. Here's the truss I was talking about, and those are the 3 columns to be removed. And the way we accomplished that was with concrete jackets, and we jacked this structure up above the where the columns were cut, and we transferred the load entirely to this truss, measuring deflections. It was done pretty carefully, constant monitoring. So anyway, that worked out good. And I think this is a case where it probably makes more sense for the engineer of record to do this than another engineer, because we know more about this project. The second part of my presentation is going to be about inspection. Section 10.1.1 states that the concrete repair and rehabilitation construction shall be inspected as required by the general existing building code or as required by the local jurisdiction. Or where I do most of my practice in Chicago, the code says nothing about it. So the code suggests in the commentary that in the absence of such inspection requirements, the licensed design professional should recommend to the owner that the concrete repair and rehabilitation should be inspected during various phases of the work. And there's many reasons why it should be done. These are some of them. It is the owner's best assurance that the work will be done in accordance with the contract document. Gives the LDP the chance to verify the quality of the work. We can better control the quantities of work required, and we could document the quantities. And the truth is that no matter how careful we are, existing conditions vary throughout the project, require modifications to details. We consider our details to be generic. At each spot they're used, it has to be specific. We can assist the contractor to solve problems found during the course of the work. Most of these are not cost items. It's just one way of doing it or another. And we can verify that the required quality control procedures and tests are being performed. The licensed design professionals shall include in their contract documents testing and inspection requirements applicable to the project. These requirements are usually included in the project specifications. The commentary lists several of the types of tests or inspections that could be done. And inspections should be performed either by the licensed design professional or repair inspectors. Eventually, after the ICRI develops their certification methods, this statement will go into code. The findings during the inspection should be documented and reporting as required by the contract documents. And if the inspections show readily correctable issues, the issues are corrected, that should be noted and documented. Nonconforming or deficient components and processes should be brought to the attention of the LDP for review and the actions to correct the deficiencies. So typically, and I'm sure you guys do the same thing, we have a inspection report, field reports, each time we go to the field with our observations, recommendations, and we like to keep running quantities on these inspection reports to let the client know where the job is. Non-conforming repair construction may include existing construction that differs from the repair documents, existing construction deterioration, distress, or levels of distress beyond those anticipated in the design of repairs. These usually result in extras, so we always tell our clients include a contingency. Sometimes we ask for as much as 20%. It depends on how confident we are on what's there. And if there's deficiencies in the construction process and the procedures, that's usually the contract's, it's in his bucket to fix it. The licensed design professional shall require that existing conditions and reinforcement shall not be concealed prior to inspection unless the LDP feels that he doesn't have to, that they don't have to inspect everything. That may be on a facade where you have hundreds of repairs, so you may just do representative. Types of items for concealment include existing reinforcement, embedded items such as anodes, new reinforcement, anchors. We wanted, just an example, we wanted to look at these anodes before the formwork went on. We're very concerned about continuity and that they're in the right place and that they didn't wire the anodes onto the coatings. Repair material test and test frequencies shall be specified by the licensed design professional in the contract documents, and it shall be reported as required by the contract documents in the general existing building code. The licensed design professional usually must rely on the manufacturer's data for proprietary materials. Sometimes, if there's a doubt that the manufacturer's installed material does not conform to their published values, they will come out and test. Or it could be an independent testing agency, but we have done this. Testing of conventional in-place concrete should comply with the testing and frequency for new construction, and construction observation shall be performed as required by the contract documents. This is, I think, a really good case study to show you. This is the installation of a lightweight concrete bonded overlay in a parking garage at the lower levels of a 50-story building in downtown Chicago. The lower 9 levels here are parking. And the garage was repaired many times. A lot of delamination. We were really concerned. It's 350-foot long building. No expansion joints, and the garage isn't heated. And it's lightweight concrete. So prior to the start of the production work, a mock-up was installed, which was extensively tested. The testing would include tensile bond test of the overlay concrete to the substrate. And because this is lightweight concrete, we had to make sure that we matched the aggregate as closely as possible to the original aggregate so that it would behave the same. I did quite a bit of talking with the people here at ACI, Ward Malich, and we found a way of doing this. Very important. So here's the contractor decided that the best place to do the mock-up was at the highest level so they can get some sense of how long it would take to buggy the concrete up. This construction, or this mock-up, was done with jackhammers, very conventionally prepared. They were actually going to use hydrogen demolition for the production work, but that was not practical for the mock-up. This is after the mock-up was cleaned. We buggered the concrete up, we put it in. This is the testing of the concrete, pretty much the same as for new construction, although it's lightweight concrete. And then we did a pull-out test. And we got these values, and we weren't too worried about it. We thought this was okay. But extensive testing of the repair construction work was performed throughout the duration of the project. We did pull-off testing as recommended by ICRI. We wanted to confirm the adequacy of the bond overlay to the substrate. So here's a hydro demolition being done, concrete being placed, and there's the completed work, and here's our pull-out test. But lo and behold, we got some really good values and some pretty crummy values. This 32 really bothered us. So we did a petrographic on it, and so we found. The reason was that the contractor didn't do a very good job of cleaning the surface of the concrete and left the residue. This is very weak surface at the bond line. So the actions taken to improve the bond strength, the contractor had to improve their methods to clean the surface of the substrate and remove all residue, and our inspectors had to step up their act too. So the results are better, not perfect, but they're better. We got some really good results. We took a photograph of the bond line, and we see this is excellent. This is probably more important than the actual pull-out test, because you can see that the really nice bond. So in conclusions, the construction phase of the work must be done with high-quality workmanship and materials that satisfy the intent of the construction documents. This code assigns certain responsibilities to the LDP during construction regarding quality assurance that they must understand and follow. Thank you.